Hello everyone. Today we are going to study about the Theodolite survey. This is our sixth lecture of the first unit, right? So we'll go into deep and we'll see what we're going to study today, right? Checks in closed traverse, right? And checks in open traverse. So before we move into the checks of closed and the open traverse, why do you think this is necessary, right? When you set up or when you construct the traverse, it might be an open traverse or it might be a closed traverse. Once you do it, how to know whether what you have set up or what you have constructed on the ground actually is correct or not? For that purpose, we have to check it. Right? There are various different methods to check the whether the traverse is correct or not. Right? So for this, it becomes very important, right? If we don't know whether your traverse is correct or not, whether it is 100% correct or not, so that will help us. Otherwise, the readings that we are going to get from that surveying will be of no use, right? So first, we'll understand the checks for the closed traverse, right? Check in closed traverse. A closed traverse should be checked for errors in linear and angular measurements. What it says is, in the closed traverse, we have to check for the errors in both linear measurements as well as the angular measurement. What is linear measurement? Linear measurement is a distance that we measure, right? When we set up and when we get the bearing of any line. So at till what distance you're going to set up it? At what distance will be r from with respect to the q or p, right? So that is a distance that we are talking about. And angular. So in the case of closed traverse, the angle may be most of the times it is an included angle because we are going to measure the included angle, right? So we are going to check the angular as well as the linear measurements. We are going to check for the errors in those angular and linear measurements, right? Check for linear measurements to avoid errors in linear measurements. The measurement should be carried out by different parties on a different dates in the both directions. Both directions is what? If this is your line A and B, so the line should be measured by different parties, right? The line, right? This is your line, okay, and you have to measure the distance by different parties. Means not once those who have been setting the traversing or constructing the traverse, but other than those, right? Just come and check whether the distance that which are they are telling is exactly same as that is on the ground, right? So at different dates at different time, okay, different people should come and check whether the distance that has been told exactly on the ground is in the paper or not, or whether whatever the readings are there in the paper are there on the ground or not. That is to be checked. One more thing, and it is to be checked in the both directions. If you measure the distance from A to B, from A point to B point, again you have to measure the same distance from B point to A point. That is in the both the directions you have to measure whether the length is same or not, right? Right. Next is to avoid the linear measurements. The measurement should carry out by different parties on different dates on the both directions. That is for the linear measurements, right? And then check latitude and departure, right? To check for latitude and departure, that is summation of latitudes is equal to 0 and summation of departures should be equal to 0, right? If this condition is satisfied, that means there are no errors in the linear measurements. Okay, there are no errors in your traversing through linear measurements, right? If there is, if this condition is not satisfied, if summation of latitude and summation of departure is not equal to 0, then that condition or that is called as closing error. There is an error of closing of the traverse, because this is, we're talking about the closed traverse, right? And then you have to balance it. Balance is what? You are going to correct those closing errors. You are going to correct it, right? So you are going to balance it. Now, in the closed traverse, you have to check for the angular measurements also. As we talked about that, we have to, in the closed traverse, you have to check for both angular as well as the linear measurements, right? So now, once you have measured with the angular measurements, right, linear measurements, you are going for angular measurements. In the angular measurements, you have two options: either check the error in the included angle or check the error in the deflection angle, right? So there are some formulas through which you will get the interior angles, right? So if the traverse, right, if the traverse is some polygon, right, you have, when you sum the angles, it should be equal to some summation, right? So that can be proved. I will go through it. Let's check. Traversing by deflection angle. Sum of, it's not deflection angle, the traversing by included angle it is. It is not by deflection angle, it is by, it is a mistake, it is included angle. It is included angle, right? So sum of measured interior angles should be equal to 2n minus 4, right angles, where n is the number of sides of a traverse. Whatever the interior angles are, they are right angles, and if they are right angles, right, then the sum of the measured interior angles should be equal to 2n minus 4, right? And where n in the formula, if you measure the interior angles of all the station points, right, and you sum it, that should be equal to, that sum should be equal to 2n minus 4, right? It should be what? It should be equal to 2n minus 4. If it is equal to 2n minus 4, then what happens? Then it means that you are there are no angular errors in your traverse, right? This is with the help of the interior angles. If you have exterior angles, right, this is when you measure the angle with respect to the interior angles. If you have sum of exterior angles, if you and that is equal to 2n plus 4, right angles, then it is that your traverse is has no errors in angular measurements, right? If you sum the exterior, that is what, if you have included angle, If you do it by minus it by 360 degrees, that will give you the exterior angle, right? Same way, if you have exterior angle and you do the summation of it, and that summation is equal to 2n plus 4, right? Then if it is equal, then it is, that means it has no errors. Next is, you can check whether the traverse is correct with the help of the deflection angle. Now, how you are going to check it? Here also same thing. Sum of deflection angles should be equal to 360 degrees, considering all the angles to satisfy the above condition. When you do the summation of deflection angles, that is, if the angle is deflecting towards the right side, means it is a right side deflection angle, then the value will be positive. If the deflection is along the left hand side of the line, then it is a negative angle. So you are going to use the algebraic summation here. You are going to use the sign, and if it is equal to 360 degrees, when you sum all the deflection angles and it is equal to 360 degrees, then that means that your traverse is correct and it has no errors, right? Traverse by direct observation of bearings. If you check the bearings of the traverse, right, if the fore bearing and back bearing has a difference of 180 degrees, all the fore bearings and the back bearings lie on the same line, so it should be 180 degrees. If there is no change or the difference between the fore bearing and the back bearing of all the points are 180 degrees, then that means there are no errors in your traversing. What it means? It means there are no errors in your traverse. In the angular way, what are the methods you can follow? That is, first one is the included angle, where the sum of the included angles that you have measured in the traverse, sum it, and it should be equal to 2n minus 4, where n is number of sides of a traverse, right? So if it is equal to 2n minus 4, then it is correct. If you have exterior angles, right, then the summation of the exterior angles of the traverse, right, should be equal to 2n plus 4. And if you have deflection angles for a closed traverse, then the algebraic summation of the deflection angles, if it is the right deflection angle, then it is positive. If it is the left deflection angle, it is negative. So if the algebraic summation is equal to 360 degrees, then that is, or sum of the deflection angles will give you if it is equal to 360 degrees, then it means that there are no errors in your traverse. One more method is by bearing. You have to check the bearings, fore bearing and back bearing of a line. If the difference of those bearings is 180 degrees, means there are no errors in your traverse, right? These are the checks that you can do for the closed traverse. Now we have to study it for the open traverse. Now how to check open traverse? It becomes very much difficult because we don't know the terminating point. We don't know the position of the terminating point, right? So it becomes a little bit difficult. We are going to use the geometrical properties of the structures through which you can able to understand or you can apply the checks to get whether the open traverse is correct or not, right? Check in open traverse. The angular and linear measurement in the open traverse cannot be checked as whole directly. We can't directly go and measure the angular and linear measurements, okay, right? Directly. Indirectly you can measure it, but directly you can't, right? So what the check you are going to do is here, running cut off line is a method through which you can check for a open traverse. What it is? Running cutoff line. What it is called as? Keep in mind, running cutoff line. So what you're going to do here in this is, if if you have a open traverse P, sorry, P Q R S T, right? If this is a traverse, this is the shape of the traverse. If this is P, this is your Q point, this is your R point, this is your S point, T, U and V, right? So if this is an open traverse, now what you're going to do is, you're going to join if you see, this is a one part of a traverse and this is the another part of a traverse. This is one, this is two. So what you're going to do is, you're going to try to close it like this by drawing an intermediate line, right? What are you going to do? You're going to have a cutoff line from P to S, right? This is a called as cutoff line. What it is called? PS is called as cutoff line. It is called as cutoff line. You're going to divide the traverse into two parts, and you're going to join the first and the last point of that division, right? So that you know that we know the S point, right? We know the P point because it is known for us. We can't go directly for the last point because we don't know its position. So you're going to draw a cutoff line, that is PS. We have drawn it in dotted line. Now what you're going to do is, right? What are you going to do is, you're going to measure the length of the PS and SV. If this is also it is there, you can check here also. You can. This is what is cutoff line. You're going to measure the distance between PS. This distance you're going to measure here. You're going to measure this distance here, right? That is PS. Okay. Once you measure the distance, you're going to check the forebearing and the back bearing of PS. You're going to do two things. You're going to measure the distance of PS and SV, right? And you're going to measure the forebearing and the back bearing of PS and SV. Now you're going to calculate, once you have got the forebearing and back bearing and the distance, you're going to calculate the latitude and departure for all the open traverse, right? You have two open traverse. You have divided the whole open traverse into two parts, right? PQRS is one traverse and STUV is the second traverse, right? So separately you are going to check for the latitude and departure. For that you have to first calculate the latitude and departure for PQ, QR, RS and PS, right? PS also is a line. It is a running cutoff line. So you are going to measure its latitude and departure. And if its latitude and departure is equal to 0, then that means your open traverse is correct, or that means there are no errors in it. Now you might say, why to divide this open traverse, right? You might say that why to divide this open traverse, right? Sometimes what happens, the direction of the open traverse may not be the same, right? In this case, what we did, we took the same direction like this, right? But sometimes your traverse may be like this. One minute. Your traverse may be like this, right? So what happens? This becomes a different one. This becomes a different part, right? This becomes a different part. So we can't put the cutoff running cutoff line, right? Running cutoff line we can't put for this. So we have to divide it and put the cutoff line for this part separately and this part separately. If it is in the same line, you can go for it, no problem. But sometimes it not always that it are in the same direction. It might change its direction. So whatever the area or whatever the traverse is on the same side, you're going to take it, draw the cutoff line, measure its distance, measure its bearings, forward bearing and back bearing, then calculate latitude and departure. To calculate latitude and departure, require distance and you require theta. So for that, you're going to measure the bearing and forward bearing of the that running cutoff line, right? So that you can calculate the latitude and departure of all those lines which is in the selected open traverse, right? Once you measure it, sum it, and you check whether the summation is equal to 0, right? If it is 0, then there is no error. If there is a difference, it is not equal to 0, then means there are closing errors in your, or there are errors in your traverse, right? That's for today. We have studied what are the checks that you are going to apply, and the checks are different for the open traverse and the closed traverse, right? And in the closed traverse you look for the angular measurement as well as the linear measurements. Here in the open traverse you only looked for the linear measurements, right? So depending upon the type of traverse, you have to check for the errors in that traverse, right? You understood how to check and what are the types of check what you are going to do for open traverse as well as for the closed traverse. For today's class, this is what you have studied, and then we'll meet in the next class. We'll be studying about the uh, balancing of traverse, and also we are going to talk about the coordinates of that point. We have studied here, we have understood what is latitude and what is, we have not understood that. We'll understand in the next class, right? That's all for today.